Let's now look at the most basic continuous probability distribution out there, which is the uniform probability distribution. So the uniform probability distribution has the following probability density function, or PDF. So fx is equal to 1 over b minus a for x between a and b, and then 0 otherwise, where x is a uniformly distributed variable or in other words is a variable with a uniform distribution, and a and b are two constants. Now recall that if you plot the PDF, then you get the probability density curve, which can be used to compute probabilities. So let's go ahead and plot this function. So I have here the x-axis and I have the y-axis. And then suppose that I have 2 points A and B. So let's say A is here and then B is here. So now between A and B, the function is just a horizontal line, right? And the distance between that horizontal line and the x-axis is 1 over b minus a. And then outside of that in AB interval, the curve is the x-axis itself. So now, suppose I have 2 points, x1 and x2. So let's say x1 is right here, and then x2 is here. Okay. Now remember that the shaded area in this figure, which is the area under the probability density curve between the 2 points x1 and x2, is by definition the probability that x1 is less than or equal to x, less than or equal to x2. Okay. And note that this is actually a rectangle. Right? So to find the probability that x falls between x1 and x2, we just need to find the area of that shaded rectangle. Okay. So the probability that x1 is less than or equal to x, less than or equal to x2 is going to be equal to, how do we find the area of a rectangle? We find the area of a rectangle by taking the base times the height, right? And the base is just the difference between x2 and x1, and the height is the distance between the x-axis and the probability density curve. And we know that that distance is 1 over b minus a. So in other words, the probability here is going to be equal to x2 minus x1, which is the base, times 1 over b minus a, which is the height. So this is how you compute the probability that x falls between two values x1 and x2 for a uniformly distributed variable. So in this video, we looked at the uniform probability distribution. We looked at the probability density function, and we plotted that probability density function to obtain the probability density curve. And then we derived a formula that we can use to find the probability that x falls between two values x1 and x2.